This is Euclid Book 10, Proposition 101. And it says, the square on the straight line which produces with the rational area a medial whole, if applied to a rational straight line, produces as breadth a fifth apotome. Let AB be the straight line. That's this one right across here. Which produces with a rational area a medial whole. And CD a rational straight line. That's this right across here. And to CD, let CE be applied. That's this area right across here. And this area is going to be equal to AB. Now, where did we get this AB? That is, we took the line AB, we turned it into a square, and all four sides of this square are going to be the length of AB. That's where we got that from. I explained that in the last video. And we're going to produce CF as the breadth. I say that CF is a fifth apotome. For let BG be the annex to AB. This is going to be the annex to this. Therefore, AG and GB, this line right across here and this line right across here, they are straight lines. They are incommensurable in square, which makes the sum of the squares on them medial. So if we add these two together, these two areas together, we get a medial area. But twice the rectangle contained by them rational. Okay? So we make this rectangle here, and I told you how to do that in the last proof, okay? We multiply this area by 2, and we get a rational area. That's by Euclid Book 10, Proposition number 77. To CD, let there be applied CH. This, and this. All three of these areas are going to be applied to this. And that area, this, and this, is going to be equal to this. This, and this, all three of those areas combined is going to be equal to this. And this area right here is going to be equal to this. Therefore, the whole CL, this, and this, is equal to the sum of this area and this area. But we already established that the sum of these two areas is medial, so therefore this, and this is also medial. And it has been applied to the rational straight line CD. Okay, it's going to be applied to this. Therefore, it's going to produce the CM as the breadth. Okay? Therefore, CM is rational. This line here is rational, and it's incommensurable with this. That's by Euclid Book 10, Proposition number 22. And since the whole CL, this, and this, is equal to the squares on AG and GB, since all of this is equal to this and this, and in these, CE is equal to the square on AB, which is this, therefore the remainder FL, okay, hang on just a second here, I'll turn this down, there we go, sorry about that, therefore the remainder FL, which is this, and this, is equal to twice of this area. Okay? So you take this area, you multiply by 2, you get this, and this. That's by Euclid Book 2, Proposition number 7. Let then FM be bisected at N. Let this line be bisected right here. And we're going to draw NO. And NO is going to be parallel to either CD or ML. Therefore, each of the rectangles FO and NL, this is rectangle FO right here. That's FENO. That's rectangle FO. It's going to have the same area as this. NL, that's this and this combined. These two areas combined is going to have the same area as this. This area is going to be equal to this area. Okay? Now we already know that this area multiplied by 2 is rational, and it's equal to FL, which is this right across here, this, and this. Therefore, FL is rational. This area and this area and this area combined is rational. And it's been applied to EF, producing FM as the breadth. Therefore, FM is rational. This line is rational. It's commensurable with this. That's by Euclid Book 10, proposition number 20. Now, since CL is medial, and I'm sorry about my voice, since this, and this, all four of these is medial, and FL is rational, this, and this is rational. Therefore, CL, this, and this, whole area here, is incommensurable with this, and this. But as CL is to FL, as this, and this is to this, and this, so is CM to MF. That's by Euclid Book 6, proposition number 1. Therefore, CM, right here, is incommensurable with MF. That's by Euclid Book 10, proposition number 2. And both lines are rational. Therefore, CM and MF are rational straight lines. They are only commensurable in square. Therefore, CF is an apotome. Now we're going to try to declare that CF is a fifth apotome. For we can prove similarly that the rectangle CKKM, that's this one right here. How did we get CKKM? Two sides of CKKM, okay, two sides of this rectangle are going to be this length. The other two sides are going to be this length right across here. Okay? Two sides this length, two sides this length. That's how we got it. Now, this rectangle is going to be equal to that square. And this is going to be equal to the fourth part of the square on FM. And since the square on AG, that's this one right here, is incommensurable with GB, these two are not commensurable, while the square AG is equal to CH, this is equal to this, and this, and the square on GB, that's this one, is equal to KL, which is this. Therefore, CH is incommensurable with KL. This, and this is incommensurable with that. But as CH is to KL, as this, and this is to this, so is CK to KM. So is this line is to this line. That's by Euclid Book 6, proposition number 1. Therefore, CK, which is this line right across here, is incommensurable with KM. That line right across here. That's by Euclid Book 10, proposition number 2. Since then, CM and MF. Well, what's CM? That's this line right across here. What's MF? That's this line right across here. They are two unequal straight lines. And a parallelogram equal to the fourth part of the square on FM and deficient by a square figure has been applied to CM and divided into incommensurable parts. Therefore, the square on CM, that's this one right here, is greater than the square on MF, which is this one right here, by the square on a straight line incommensurable with CM. This is by Euclid Book 10, proposition number 18. And the annex FM, which is this right here, is commensurable with the rational straight line CD set out. Okay? This is commensurable with that. Therefore, CF is a fifth apotome. And that is by Euclid Book 10, third set of definitions, number 5. And that's the whole proof. I will tell you more in a future video. We only got one more proof with this diagram, and then this diagram goes away. So, I will tell you more in a future video. Stay tuned.